I would like to know that whether all of you have understood well about floating point representation and multiplication by array multiplier method and Booth's algorithm. If anyone has any kind of problem in these three topics, then they should clear it. Because questions on these topics would be surely appear on your examination, university examination, and as well as internal examination. So are you all able to see the notepad?
Yes, sir.
Yes,
Okay.
sir.
So you might have paid attention about the syllabus topic, that is fixed and floating point representation. That's it. So first of all, we have discussed about floating point representation because you have heard of float and double keywords in your C programming, right? So in C programming, when you are using the float data type, then you are telling the computer that the fractional numbers are to be stored in 32 bits, and for double keyword you can use the double expansion, that is 64-bit expansion of fractional number representations, right? So these two formats were also called as XS 127 or XS 1023 exponent representation, right? So have you all worked on these numericals for representing decimal numbers into binary with single precision and double precision? The topic which we are going to discuss today is about the fixed point representation. As you can see, the number which is written in the first row, which I have highlighted, it is 00543.218000, right? So this kind of number is having the number of significant digits is equal to 5, 1, 2, 3, 4, 5. These are significant digits, and the radix or base of this number is defined as 10, and point is a decimal point which is separating significant and fraction. So 543 is called as significant, right? Now what is fixed point representation? Fixed point representation means the position of the point that is separating the significant and fraction is fixed, right? Whereas floating point, in floating point you can have any number of significant digits as per your choice or requirement for the computation. For example, the same number above can be represented as 5.43 into 5.43218 into 10 to the power 5, right? So this is the scientific notation of the decimal number. Similarly, when a binary number is going to be represented with fixed point representation, then we would be representing it in 32 bit with one bit, that is MSB, the leftmost bit taken as representation of sign. That means 1 for negative and 0 for positive. Next 15 bits would represent integer and subsequent 16 bits would be used for fraction. So in this way, we can represent our binary numbers in 32-bit with fixed point representation. Fixed point representation in binary number, fixed point representation of a binary number in 32-bit involves leftmost bit, or it is also called as most significant bit, MSB, for sign, 15-bit for integer, and 16 bits for fractional part. So we are having another definition, normalized floating point, normalized representation, you can see, not exactly floating point, but for 4 types of representations. What is normalized representation? The MSB, most significant bit, must be equal to 1. Right? This is called as normalized representation for binary representation. Here MSB means most significant bit. So bit is basically used for binary number. So when we are representing numbers in binary, then we are having most significant bit is equal to 1, and it is not recorded, or this is called as hidden bit. So in short questions of 2 marks, these kind of things. Okay. These kind of questions may be asked that what is hidden bit in uh, binary numbers representation. So whenever we are representing binary numbers as per normalized representation, the most significant bit 1 is not recorded or not saved or not stored. Suppose the number is 1, decimal point is also not shown in the register storage, but it can be understood theoretically. Suppose the number is 1.1011 into 2 to the power 5. So this means that the binary number is represented in normalized representation, right? Now suppose the precision is given as single, or you can say 32 bit. Then what this number actually is, the significant, or you can say this one which I have highlighted, is not stored on the register at all. Only fractional part is saved. Now this number with single precision, that means 32 bit representation, would be actually saved on computer. Like, since the number is a, not a negative number because negative is not written, so number is a positive number, so 0 is the sign bit. Now see, 5 is the exponent over the radix 2, because in binary system the radix or base is 2. So 5 is the exponent. Now you recall that I had told that in single point, in single precision representation, we have to store our exponent in excess 127 form. So excess 127 means 127 plus 5. That means 132 is going to be saved as, stored as exponent. So we have to write 8-bit exponent for the decimal value 127 plus 5, right? So how would we are going to obtain 133? So you can simply write like, how you can be able to build 133. So you would need 127, 4 and 1, right? 127, 4 and 1. 127 means 2 to the power 7. That means 0, 1, 2, 3, 4, 5, 6, 7 would be indexes for the numbers. So for 2 to the power 7, that means a 1. Then for 2 to the power 2 and 2 to the power 0, we need to have enable bits or 1, and other bits would be 0. So the representation would be 1, 0, 0, 0, 0, 1, 0, 1. So this representation is equivalent to excess 127 of the exponent 5. That means 127 plus 5, right? So this way you can store the exponent, and again the fractional part is 23 bits. So this fractional part would be stored on the register in 23 bits. So 7 bits is written here. So 16 more would be required. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this would be the exact representation of this number inside the computer registers. Understood this thing?
Sir,
Huh.
सर पावर का रिप्रेजेंटेशन एक बार फिर से बता दीजिए।
बेटा the number is given in the power 2 to the power 5, right? In question it would be mentioned that you have to store the number in either single precision or double precision. ठीक है? So single precision is of 32 bits and double precision is of 64 bits. In single precision representation, 1 bit is for sign, 8 bit is for exponent, and 23 bits are for fraction, or this thing, right? And in 64 bit, 1 bit for sign, 11 bit for exponent, and 52 bit for fraction, right? In this example, I had told that we need to store this normalized binary representation. Why this is normalized? Because we are having only significant bit 1 before the radix point or base point, right? So whenever you will find the number with only a single symbol before the radix point, then it would be normalized representation. For example, in our decimal system, this number 5.43218 into 10 power 4, 10 power 5 is a normalized representation. Why? Because before this decimal point, I am having only one significant bit, a significant digit, right? So in binary, obviously the numbers could be represented as, अब यहाँ पे अगर 0.10 लिखेंगे तो वो नॉर्मलाइज्ड नंबर नहीं है. For a binary number to be called as normalized representation, always before this radix point there would be 1. So when this is always the case, we need not to store this 1. That's why it is also called as hidden bit, because it is not stored on the computer registers. Okay, this is the uh, concept behind the hidden bit. Now this is 5. When single precision would be used, that means 32-bit representation would be used. This number is to be stored in excess 127 exponent form. So 127 plus 5, that is 133. So convert 133 into the binary. So we are getting this sequence. So this sequence will be stored as the exponent. And since the number is positive number, we are storing a 0, that is leading bit representing the sign of the number. And this remaining fraction would be copied same, means stored like same, but with trailing zeros to accommodate 23-bit length, so that it is obviously understood that the radix point lies here, right? If this number has to be represented in 64-bit, that means double precision, then we have to add 1023 plus 5, so 1028. So 1028 would be represented in the 11 bits here, sign bit as the first bit, and exponent would be copied again here, but not in 23-bit but in 52 bits. So 52 bits would be written here, right? डाउट क्लियर हुआ?
यस सर.
तो इस कंसेप्ट पे आपको डेफिनेटली एक क्वेश्चन मिलेगा और बूथ एल्गोरिथम पे डेफिनेटली एक क्वेश्चन मिलेगा, 2 क्वेश्चन एकदम पक्के हैं, ठीक है। ये हर एग्जाम में आपको ऑप्शन से मिल जाएंगे, मतलब अगर 5 क्वेश्चंस में से 3 क्वेश्चंस करने हैं तो उन 5 क्वेश्चंस में ये 2 क्वेश्चन आपको जरूर मिलेंगे। डिवीजन बहुत कम पूछा जाता है, मोस्टली बूथ एल्गोरिथम मल्टीप्लिकेशन ही पूछा जाता है, ठीक है। In next class we'll discuss about the division by applying 2 algorithms and 2 procedures. फिर से recap समझ लो। Fixed point means radix point position is fixed, and floating point means radix position may flow. That for example, this number could be written as 54.3218 into 10 to the power 4 or 543.218 into 10 power 3 or 0.5 into 0.543218 into 10 to the power minus 2. So the place of decimal can float, then the number would become floating point representation. And if the representation of decimal point, radix point is fixed, then it is called as fixed point representation. So normally the computers are nowadays use floating point representation so that the computation can be adjusted. Adjusted how? Suppose you have to add 2 numbers. So the length of the fractional parts must be same, then it would be easy for the computer to compute. With varying the significant numbers, or if 2 numbers are to be subtracted or added, then their radix raised to the power number must be same, then only they can be added. That means if 2 numbers are represented in 2 to the power 6, then simply they can be added with integer parts added and fractional parts added and carry forwarded to the integer part. So with floating point representation, it would be easier for applying arithmetic operations on the binary numbers. That's why the computers use floating point representations. Now see, in floating point representation, we have up to 23 bits in single precision and up to 54 bits in double precision. So it would have a very precise accuracy to a large extent also. For example, if we are using the fixed point representation, we may have the largest number 32768 in 16-bit representation, because 2 to the power 16 2 to the power 32-bit representation, because 2 to the power 32 would be approximately about 32768. So the range would vary from minus 32767 to plus 32768. ये आपने जब डेटा टाइप्स पढ़ा होगा सी में, तो नंबर्स की रेंजेस पढ़ी होगी, याद करो 32767, 32768 -2 प्लस रेंजेस यू माइट हैव स्टडीड। उस समय आपको शायद समझ में नहीं आ रहा होगा क्या है, बट now times you can able to understood this ranges well, and